I'm going to talk a little quick bit about my research. I'm a part of the ASL Avatar project where the goal is automatic translation of English to ASL. Using analysis from motion capture data, we can automate parts of the animation process as to reduce time and cost. Now for this project, I am focusing on the chicken angle, which can be understood as the angle of the elbow in relation to the shoulder or the body. The data set I'm training my model on is a 3-minute clip of an ASL signer with the variables subsetted focusing on the upper right body. Now, the goal is to use the captured variables such as wrist distance or wrist angle so that I can predict a good estimate of the chicken angle, which currently is a parameter that the animator selects. Therefore, if I can predict it, I can reduce some of the time and cost it takes to animate. Now, my previous research resulted in a fairly decent linear model with only 5 variables that had a 17.5 average root mean squared error across all 8 data sets. However, this does not take into consideration the sequential nature of motion capture data, and therefore, for this project, I wanted to explore recurrent neural networks to see if that can capture some of the information of the sequential data to improve my model. Now, to start with, I'm using grid search for parameter selection. I have 3 layers in total in my network. The first one is a long short-term memory layer with 100 neurons. With these parameters, I train my data on my data set, and for testing, I have 7 other data sets with the same variables, but with either a different assigner or a different phrase. And so the goal or the RMS value I had calculated earlier on my linear models was trained on this first signer, first phrase, and then the model applied throughout the other 7 data sets to see what the average is, to see whether or not the model can generalize. And so we can see in the results, and it might be a little bit confusing at first, so I'm going to clarify. Let's look at the reduced RNN and the reduced linear first. So this is my original linear model, and the reduced RNN only really decreased the RMSE value by about 1.5 degrees. It's not really what I had hoped for, and I've just highlighted where it performed better. It does look like, though, that it generalizes a little bit better. We don't see this very large error come through, and it does seem to be more even throughout the different signers and different phrases. Now, because I was a little disappointed as a result, I decided to expand to the full data set with all 22 variables in order to compare to see if that made a difference. And interestingly, using the linear model, the full data set achieves about the same RMSE value. As is due to overtraining, you'll see that the training error is very low compared to all of the other ones. Now, the same is true of the recurrent neural network, but it did perform better than the reduced neural network, which makes me think that there are some variables in here, not in here, that can be quite important for my model. Now, another interesting thing to know is that these two, where the linear model performed better, are both the same signers. They're doing 2 different phrases, but it's the same signer. And so that leads me to my first conclusion, which is that it really does seem like the recurrent hidden state is capturing the style of the signer, and so trying to generalize that across the board to different phrases and different signers can be hard. And so perhaps the second signer had a very different style, and therefore it was hard to predict. And this is just the same point I made that was very surprising, that the sequential nature of the recurrent neural network did not add much to the linear model. And here I sort of want to conclude that the linear model is still very simple to visualize and to explain, whereas adding the complexity from all the hidden layers does decrease my RMSE value. However, it is quite a complicated network and it's very hard to sort of understand what is going on. However, the model that I did get is more stable across the different data sets, and so I do want to look more into exploring RNNs for this project. And so some things for further work is to visualize the network to see which variables are really contributing and which ones can be dropped. Dropout could be a good technique to try and to increase the generalization capacity. And then I really want to be able to combine these separate data sets in a way, either through averaging or perhaps to artificially expand the data set using a little bit of noise model to the human motion to see if I can get a better network. And that's it. Thank you.